I'm Wes Hummel. I run site reliability engineering for PayPal. And today I'm going to talk about a really cool journey that our SREs have been going on the past couple of years to improve availability through failed customer interactions. Before we talk about that, I want to talk more about PayPal and why availability is important. So PayPal is unique because we're a two-sided network. We have over 220 million consumers and over 18 million merchants. And our growth fuels this two-sided network. When we get more consumers to sign up for our site, it becomes more attractive for merchants to offer PayPal as a payment solution. And when we have more merchants that accept PayPal, it becomes more attractive for consumers to sign up. And so that keeps that virtuous cycle of consumers and merchants growing. And this growth has enabled us to be a company that accepts payments in 100+ currencies and in over 200 markets. Last year, we had $13 billion in revenue, and really impressively, 7.5 billion transactions, which resulted in almost $500 billion in total payment volume. Now, about a third of this payment volume was mobile payment volume, and about a third of our transactions as well. A little bit of trivia. When I started PayPal in 2008, and I realized that probably some of you in this room were in middle school, so I understand that. But when I started in PayPal in 2008, we had $23 billion in transaction volume. So we've grown about 20x. But more impressively, in 2008, our mobile transaction volume was around 24 million. So it used to be 1,000th of our payment volume, and now our mobile payment volume is about 1/3. So explosive growth in mobile. So what does $500 billion in payment volume look like? Well, it looks like a little over $16,500 a second. For those of you that like round numbers, that's about $1 million a minute. And those $1 million that we're transacting are consumer to consumer, consumer to merchant, and this is people's money. The job of a site reliability engineer at PayPal is incredibly important because when you're dealing with people's money, it's really bad when things don't work. And it's really important that we minimize the amount of time that we're impacted. So obviously availability is incredibly important. So if availability is important, and even when we were doing $23 billion a year, availability was important, how do we measure this? Well, we measure it differently today with FCIs, and I'll go into how we do that. But first I want to talk about how we used to measure this, right? Now, I know some of my engineers out in the audience will probably recognize this. Graphs are like Rorschach to SREs, or they look at it and go like May 3rd, 2003. I was, sitting at Johnny Rockets when this happened. I took some of the information off as far as date and time to protect the innocent. But the way we used to measure this is we used to take a major incident that would happen on our site. And you can tell when things go south. The blue are the transactions that we're processing, and the yellow areas are transactions we should have been processing. So bad situation here, about 2 hours. So we would take that time frame and we would say, how many transactions should we have been processing and how many did we process? In this case, let's say we should have been processing about 1 million, and let's say we processed about 700,000. That'd be about a 30% impact to our payments. So we would take that 2-hour window, 120 minutes, and we'd say, okay, 30% impact, 36 minutes impact, 2,160 seconds, right? And that would be our impact to availability. And then we would just simply run an equation that says, for that day, for that month, for that quarter, for that year, whatever the total possible available time was, we subtract out all of the impacts that we've had to our site, we divide by the total, and voila, we have availability. Pretty simple, right? Clock time availability, if you will. And we didn't necessarily have good attribution to this, right? This could have been a database issue. This could have been due to a code roll. Usually we blame the network folks. So we'll say, oh, this was a network issue, clearly, even though I don't remember what it was. So the attribution on who actually who actually had the action to do something about this was art more than science. So, what's wrong with that model? Why doesn't that model work? Why doesn't that model help us in running a $500 billion payment volume business? Well, first off, it assumes that we're at 100% all the time except for that window, right? That top of that yellow line is derived by saying, what's the 6-week average for this time of day, this particular minute? Let's go look at what it should be, and let's delta. So you're assuming that you're running at 100% all the other times. You guys are all SREs, and you know we don't run at 100% all the time for availability. We only did this for major site issues. So there's things going on all the time. The death by 1,000 cuts. There's blips here. There's bad issues on the site. There's code issues on the site that may not be impacting us as significantly. And we're not measuring those. So we really only took that window of time that we knew we had an incident and measured just that. Right? It only factored in payment impacting issues. Now, this was very much an inward-looking view. We're a payments company, but we don't only do payments. We have to onboard customers. Customers have to look at their history. They have to change their preferences. All the things, the services and products that we offer our customers aren't all payments, and that's all we were looking at. So if we had customers that couldn't check their history for 3 weeks and we didn't have a site incident, yes, 100% availability. No. So it really didn't reflect how our merchants and our consumers were feeling. It didn't reflect the sentiment of our products and services and how available we really were. So we needed a new measurement. And this new measurement needed to account for all of our experiences. It can't just be about our payment impacting experiences. If we're going to be customer-focused, customer champion company, we have to look at all of our experiences that our merchants and consumers use, and we have to understand what the availability is for all of them. It has to be actionable. So we can't just blame the network guys all the time. They're getting kind of tired of that. And so we really have to make sure that we can derive the insights, we have the understanding of what's broken, and we can have the right people go in and fix those things. It has to have the proper attribution. So not only does it have to be actionable, not only do we have to get the data and be able to do something very quickly with it, but we really have to understand what services we should be looking at and what needs to be fixed, right? And we can't pick a measurement that requires us to train 5,000 developers how to change their logging standards, how to do something different from their instrumentation. It's not a scalable solve. So, enter FCIs. Now, when we first went down this path, we said, okay, let's be greenfield about this and think about what should the definition of an FCI be. We may not instrument it that way at the beginning. We may pick a subset of the problems that we have. But what should it be, right? And our definition is that an FCI is when we have a failure, it's when we have an intended action that our customers want to do that they're unable to do with functionality that we provide, so it can't be something we've deprecated, something we don't have anymore, and is allowable by PayPal policies. Now, that last part's important because, we may have a customer that fails because their credit card got declined. That's okay. That's not an FCI. That's just your credit card got declined. So we really had to make sure that we have compliance issues, we have risk policies, we have things that are in place where people aren't necessarily going to be able to do the action that they want to do, but it didn't necessarily make it a failure, right? So the engineers on our team are going to be really happy that I took about 2 to 3 months worth of creativity and innovation and boiled it down into 2 diagram slides, because I think, I'm a manager and that's actually in my job description. But what was really important about how we implemented this was we took all the inputs into our services. So this is an example of where we might have web input, right? We may have a web transaction. That hits Akamai, goes to our PayPal servers, and then lands in a service we call Slingshot Router. Now, Slingshot Router does a lot of things. It routes transactions to the proper front-end applications. It also has retry capabilities and things like that. But the important thing about what Slingshot Router does in this case is that we take that request, we say, okay, here's a request for sending money or checkout. And we tack on what we call a correlation ID. That correlation ID actually keeps track of that transaction throughout all the service calls so that we can stitch that entire transaction together again and understand whether it was successful, and if it wasn't, where it failed. Right? So the key part here is that we have that correlation ID. So when we actually have a failure, we return back up through Akamai. Akamai not only now has all of the information like the URL, the time, status, but we have that particular correlation ID. We store that off in the Splunk. Now we have all the information that we need about that particular transaction. So why this is important is we can then take that and say, okay, we have a status that we record for all of our services. It's going to either be a 0, which is a success, a 1, which is an error, or a 2, which says, hey, I got bad data from the service that called me, right? So when we have a transaction that fails, when we get an HTTP 500, whether it's a web call, API call, we'll actually trace through those services and say, what was the first service that failed with a 1? 2 doesn't count because you got bad data from the service that called you. So in this particular case, we had a request come in. We go to service A, everything's fine. We go to service B, everything's fine. Service B calls service C with bad data. Service C says, no, that's not good. Service B can't do anything with the response. Says, well, I got to return a 1. And then service A returns a 1. So in this case, service B is actually the offender. So we can take any request that comes in for any of the functionalities that we offer at PayPal, and we can tie the failure to a specific service. Now, that's really important because then we can drop this heat map that says, here's all our functionalities. And by the way, there's several dozen more than this. But we can look at all the transactions for a particular functionality for that day, or that week, or that month, or that year. And we can look at all the ones that failed. And we can then map it to an availability. So yellow is okay, 99.97. Green is 4 nines and above, right? Red is bad. We've been in this business long enough to know red is always bad, right? But this gives us the ability to understand how our products are performing, whether they're payment transacting products or not. The other important thing is because we know the service that failed, and all services have an owner, we know which owners have to go fix their services. Now, I left the names off to protect the guilty, but you can see that every single day you're able to go. So if you're a developer or manager, you can actually come in, and if you own a service, you can go and look and say, okay, here are all my failures for yesterday. Let me dig into them and see what they are. That top brown bar, we had a code fix that went in a few weeks ago, and you can actually see it shrink significantly. You can also see some bars that just pop in out of nowhere. You see a big spread there. Just in one day, boom, they blow up, and then all of a sudden they go back. Usually code rollback, a side incident that happened to a particular service that we fixed, a transient issue. But you'll see a lot also that are consistent every single day. This is the death by 1,000 cuts. And now we have that visibility and we have that ownership for people to go in and fix every single one of their failed customer interactions. The cool thing, too, is if you're in sales or if you're running a particular region, you can actually see how your region's performing. Now, I took this snapshot a couple days ago, but I can tell you last year it didn't look that green. Last year was yellows, some oranges. The year before, reds, and a lot of oranges. But you can actually see, how are our regions performing, right? Do we have any particular problem? And what I found interesting was we have a little red country in there. I did some searching and found that that's actually Turkmenistan, which I've never heard of before. They have had 99 FCIs this year. So to give you an idea of how much they process, in the US we've had about 2 million FCIs this year, right? And they have something like, 60 or 45,000 successes, and there's something around the order of 6 billion successes in the US. So not a lot of processing, but this gives us that visibility and ability to dig into that. And you can see below, we actually know what's wrong here. sign up is failing for them. A lot. Why? Right? Relatively a lot. They have sign up failing. And so if you're an engineer, you can actually click on that bar. You can go straight to the correlation IDs that are associated with those failures and go straight to the logs that are associated with those correlation IDs and see exactly what's failing. So you have a great ability to go fix the things that are broken. Now, when we have an issue on the site, a real site incident, this is what it looks like. So now you see we can still look at the payment impacting things. You can look at impact to express checkout, to recurring payments, direct credit card. But there are other things in there that we can look at as well, not just the payment impacting ones. We know all the FCIs are created when we have a site incident. We know all the different services that are impacted. And so we can actually quantify and say, during this particular event, we had 34,000 FCIs, right? And if you look to the left and to the right, we're not assuming 100%. We actually see all the FCIs that are occurring before and after at our normal run rate when we think there's absolutely nothing wrong with the site. Well, this became really important, and we actually made a significant amount of progress on reducing these FCIs to the point where we said, well, this is great. We're running this every day. We're fixing these things. We should see these real time. If we have the visibility into these real time, we can actually fix them on the spot, and we won't continue to increase them. So we implemented real-time FCI. So this is from one of our projectors in our command center. It's green, but when we have an issue, we'll see the FCIs almost immediately, within minutes. And we can roll back code, we can look at what changes occurred, and we actually can start to build automation into that, where we can automatically roll back code, where we can automatically undo changes that occurred on the site that caused FCIs. So, what makes this whole thing successful? Well, first, again, it's a customer view. It's not just payments that we do. Those aren't the only services that we provide as a company. And it really gives us an outside-in perspective of how we're performing. And so that sentiment that the merchants and consumers have now matches. When we have a site issue and we see a lot of FCIs, it matches what the customers are feeling. When we have a bad code roll that may not affect just payments but something else, we know about that, and this actually reflects what our customers are feeling. We have accountability. So we know the service, we know the owner, we know the director, we know the senior director, we know the VP. We can go up as high as you want. We actually know who owns these issues to go get fixed. Now, the interesting dynamic that this created was that people would be in one of two camps. They'd be in the camp of, oh my gosh, I have this awesome insight. Now I can go fix these things. Or, oh, I don't want to be on the shit list, so I'm going to go fix these things. Either way, they're going and fixing these things, right? So it's a great result. There's actionability. So again, you can drill into this, figure out where the problems are, and actually go fix them. One of the principles that we had here was that, okay, if you have failures, you need to fix them. But it's not okay to come back to us and say, no, that's a logging issue. The instrumentation's bad. Don't worry, it's not affecting customers. So it's really important that we treated the logging hygiene just as important as we did the customer issues. So we got asked to do a lot of exceptions. Can you make an exception here? This isn't impacting customers. This is a logging problem. We'll fix it in Q4 of 2020. And so no. So we really got a lot of our logging cleaned up as part of this as well. We also put together a tactical team. So this was new culturally to us, right? We actually had to go and get people to fix stuff that they didn't even know was broken. And it was a lot of stuff that they didn't even know was broken. And so we put together a small tactical FCI team to go work with those product development teams, show them how to use the dashboards, tell them what they needed to do to get these things fixed, show them how to get to the logs. And we had a lot of good results on having this team just driving and ensuring that we had these, that they were working with the teams to get the FCIs reduced. And as I talked about, the real-time aspect, which allows us to roll back code. Now, I talked about the death by 1,000 cuts. This is what a death by 1,000 cuts looks like. So this is the past several years, since 2016. The purple part are FCIs. These are raw numbers. And what's impressive about this is Blue is the successes. And so the reason it goes up is, one, our volume is going up, but two, we also didn't have full coverage of all of our services, our web flows, our API flows, right? And so as we continue to instrument those, you'll see the blue go up. And it goes up by a factor of about 10. So what you want to be looking at is the delta between the blue and the purple, which is the delta there, like that's our availability. So not only does our blue shoot up significantly, but our purple continues to go down. Our availability got much, much, much better. This next chart shows it better. I think I'm going to dub this like the periodic table of awesomeness. But this is what you want to see, is you want to see going from red and orange to green. Right? This is overall of availability. So this is all of our products and services. Right? And you can see we went from 3 nines and a 3. And by the way, those reds are under 3 nines. So anything red is 2 nines and change. Anything green is 4 nines and change. So we made a significant impact by just having the visibility into what was broken on our site. But we're a payments company. Payments is important. And so we thought, well, we ought to tier these FCIs. And so now we're actually looking at driving our tier 1s down. I snapped this about a week and a half ago, but ever since the 17, it's been green. And so we now have the visibility into our tier 1, our payment impacting FCIs, to where we can go in and I just got a bad look for jinxing things. We can actually go in and fix our tier 1 FCIs and drive our payment availability even higher as well. So, what were the results of this? Well, we reduced our systemic FCIs by over 95%. Remember, all this stuff was stuff that was already broken. These were systemic problems that we had on our site. These might exist in your products and services as well. And you can find them. So in 2017, we only had 1 day below 3 nines. And what's interesting is that day had 750,000 FCIs. That's fewer than the FCIs that we had almost every single day in the first half of 2016. And that was from a particular event. So essentially we had a site issue every single day in 2016 that we didn't know about because it was spread out over 24 hours instead of the normal 5, 10 minutes, hour that we usually see it in. We have 31 green days, so 4 9 days in 2016, and we only had 39 non-green days last year. And I'm sorry, I'm going to do this again. We've had no non-green days in 2018. We've had all days have been 4 nines and above. I know, you guys, I'm so sorry. Thank you. they're not happy with me over here. I'm not jinxing us. This is science, man. And this has all resulted in a 1% lift in revenue last year. I told you we did $13 billion in revenue. This is over $100 million. This is change between the cushions. This is failures that we had on our site every single day that we didn't have visibility into. We didn't create a new product, a new feature. We got 1% of revenue from just fixing things, which is pretty awesome. And because things weren't as broken, our call centers weren't getting a lot of calls. And that makes them happy, and that makes us happy. We had about a $20 million reduction in calls to our call center, which is huge. So between the two, about 120 million in savings in 2017, probably somewhat close in 2016. So about $250 million bottom line revenue to our company by going and fixing stuff that was broken. With that, open it to any questions you might have. Also, thank you. If you have a question, there's microphones in the middle.
Thank you for the talk. Very interesting. You mentioned that your definition includes operations that are within PayPal's policies, right?
Yeah.
How do you monitor for policy bugs?
So we, essentially right now, the way we measure this is through HTTP 500 errors, right? And so the way we measure policy is we won't return a 500 if it's something that's according to policy. What we want to do is get to the point where we can actually throw FCIs in the code. So rather than just looking for the 500s, if we have a failure path, let's say you're going down in a particular flow and you revert to like a legacy flow because you broke here, you still can fix that, but you may want to throw an FCI to say, hey, this worked for the customer, but not an ideal situation, or maybe it didn't even work for them, but didn't throw a 500. And so, basically anything that's policy and risk are things that we control and we would return a 200 for.
Right. So I guess my question is, because policies change based on your business decisions, right? And so you're now looking at tracking what the effect of those policy changes is on.
Right.
Okay.
So when we have policy changes, anytime a policy change occurs, we won't throw an error in that particular case. That'll be something that we account for in our flow logic. Yeah.
I'm assuming
let me go over here real quick and we'll go back and forth.
Thanks for sharing the numbers and the results. So question, you talked about cost savings to the company as part of results. Have you guys thought about customer satisfaction increase because of this and how that could be tied to these numbers?
Yeah, it's a good question. So NPS, customer satisfaction, have we thought about that as part of this? To be honest, it's not a metric that we went and tracked as part of this. We probably should have. We do NPS surveys and we get that information from our customers. I think the most directional view of that is our call volume at our call centers, because that is, people only call when they're upset. The detractors are the ones that impact your NPS, and the only time we get calls is when something's not working. We get the occasional, hey, everything is great, but it's 1 out of the 10,000 calls that we get. And what's interesting too is the calls to our call centers, if you just get like 1 out of every 100 people call, right? And so if you have a side issue that's the death by 1,000 cuts, you may get 1 person call in, 2 people call in. Well, our customer service agents, until they see a trend, they might think it's a one-off, right? So we have to aggregate quite a few errors for our customer service agents to be able to determine a trend. And if that happens over the course of a day, a month, a year, they don't ever see the trend, but they get called all the time. And so, yes, I'm sure our NPS went up as a result of this, but there are so many factors in that it's really hard to tie it to any specific thing.
Thank you.
I'm assuming the correlation IDs were essentially arbitrary, random strings or whatever. What kind of challenges, maybe top couple lessons learned in tracking those back to the original services?
I didn't quite get the question.
How hard were lessons learned from taking the correlation ID back to the originating service?
Yeah, it really, the nice thing was, correlation ID is something that we already had in our system, so we actually benefited from a logging standard that existed. So that was all in place and not something that we really had to modify a lot. Now, we did have to take it all the way back up to Akamai and Apache based on whether it was a web or an API service that was being called, or endpoint that was being called. But it really didn't take a whole lot of additional instrumentation in order to get that to work, compared to if you had to go and do this from scratch. Now, you can build it into frameworks in other ways, and there are different approaches you can take if this is not something you already have in your logging standards.
Just amusing question. Did you get a bonus for finding all this loose change?
I like this guy a lot. No, I didn't. What the hell, man? Okay, Jeff's saying I did. I'm not sure. I'm not sure if that's a bonus.
You got promoted.
Oh, yeah, sorry.
How do you balance this compared with other metrics such as latency, and to make sure that when you're driving so hard on this metric that you're not sacrificing anything else?
Yeah, that's a great question. Hopefully soon in an SREcon near you, we'll be doing the same thing for latency. Latency is our next problem, right? And so essentially what this helped us do, there are a lot of other metrics that we're driving. This one was like, hey, these are broken. Like, there's just no way around it. There are other things that we have to drive, but the bottom line is there are a lot of things that if we just fix these, it's a great customer experience. It's really great for our business. And so, yes, we have a whole laundry list of additional metrics that we go after now that we've kind of gotten that purple down to minimal. But it wasn't like in isolation. There are other initiatives that we're working on as well in order to make the reliability and availability of our site more robust.
Also, eliminating the obvious actually points a lot to those kind of problems.
Yeah.
That's really, latency is only a hidden problem behind a lot of the bigger problems that you have.
Yeah.
All right, so I'm going to have to do this, so I want to make sure I understand. Like in an environment with like a bajillion microservices, does the the UUID or your correlation ID, does that drop out exactly which services were involved, and then you don't have to do a bunch of digging into call trees? And so it
drops out exactly. And in fact, if you go to our FCI dashboard, you can literally click on those bars until you get to something that says download. If you have a lot, download your correlation IDs. If you have a few, here they are. And you actually click on those and get to the logs of the failures. So the correlation IDs, again, that was something that we leveraged that existed in our system already, a very robust thing that we had, but really no fallout there. Now, we often, and I love to see in the Slack channel where we have people saying, those aren't ours, and they're not returning the right thing, and I'm going to tell mom. And so, we worked through, let's get the logging right so all this washes out, but we actually had a high success rate at finding the services that were actually the offending services.
All right, thank you.
All right, thank you all very much. Appreciate it.